This video is about solving systems of equation by the substitution method. So we have the equation of two lines, and what's really happening here is we want to find the point where the two lines intersect each other. The substitution method, well, it's all in the name. We're literally going to take y equals negative 4x minus 4. So we know y equals this expression that I underlined, and we're going to substitute that into the other equation. So the synonym replace works just as well. We're replacing this expression, which we know represents y. We're replacing y in the other equation with this expression. So what we do is we replace that y that's underlined in red with the expression underlined in red in that second equation. So now we have a simple equation with one variable. We need to solve this. So if you add 4x to both sides, you get 8x minus 12. We still have a negative 4 over here. So now if I add a positive 12 to both sides, we'd have 12 minus 4. So we have 8 equals 8x. Divide by 8, and you get x equals 1. Now, remember what we're doing. We're trying to find the point of intersection. Well, points have an x value and also a y value. We have the x value. In order to find the y value, take x equals 1 and plug that in wherever you like. The first equation, the second equation, it doesn't matter. Whatever you think would be easiest. So we know that y equals, I'm going to use the second equation, 4 times x, but we know x equals 1, so 4x minus 12. So y equals 4 minus 12, which is negative 8. So what we've done is we found the point where these two lines intersect. They intersect at the point 1, comma, negative 8. And that really is the basics of the substitution method. Now I'm going to do several more examples showing you some tricks and how the questions can get a little bit harder. But that really is the basic idea. So next we have almost the same thing. One of the equations is not written in the same form as before. That's not going to cause us any trouble. Well, we know that y equals 6x plus 12, so we're going to substitute or replace that in the other equation. So I'm going to write down the second equation, 4x plus 5. Well, we know that y is equal to 6x plus 12. So what you've done is you've taken this expression underlined in green and you've substituted that in the second equation where y is also underlined in green. So now you have another relatively simple equation to solve. 5 times 12 is 60. That's negative 8. Well, 4x plus 30x is 34x. And if you subtract 60 from both sides, you get negative 68 on the right-hand side. So now if you divide by 2, negative 68 divided by 34 is negative 2. So just like in the previous question, you substitute this value wherever you like in order to find y. Now I think it would be easiest to use the top equation, so that's what I'll do. We have y equals 6 times negative 2 plus 12. Well, 6 times negative 2 is negative 12. Negative 12 plus 12 is 0. Remember, don't discriminate against 0. It is a perfectly fine number. A lot of times beginning algebra students, anytime 0 shows up in a problem, they have the impulse to write no solution. No, 0 is perfectly fine. Nothing wrong with that. So we found the point where those two lines would intersect each other if we were to graph them. They would intersect at negative 2, 0. All right, let's do another example. Increase the difficulty slightly. So there's an obvious problem with this example. Neither one of the equations have one of the variables isolated. They're both written in standard form. So what you want to do, look at the top equation, look at the bottom equation, and choose a variable to solve for. Now I suggest you choose whatever variable would make your life easiest. You don't always have to solve for y. You can just as easily solve for x. However, in this question, thinking ahead of the algebra that I'd have to do, I think it would be easiest to solve the bottom equation for y. So if you add 5x to both sides, you get y equals 5x minus 12. So at this point, we're going to follow the same technique as before. We know that y equals 5x minus 12. We're going to substitute that in the other equation. So I'm going to write the top equation. We have negative 4x plus 2, well, 2 times y, but we know that y is 5x minus 12. Now solve this equation. We have negative 4x plus 10x minus 24 equals 0. Negative 4 plus 10, so we have 6x, and I'd go ahead and add 24 to both sides. So we have 6x is 24, meaning that x equals 4. Once again, to solve for y, replace this wherever you'd like. Now here's a quick trick. You could substitute x equals 4 into the top equation. You could substitute it into the bottom equation, but you could also substitute it into this equation in green that we needed at the beginning. And I think that would be easiest. So we have y equals 5 times 4 minus 12. So we have 20 minus 12, and that's 8. So once again, we found the point of intersection of the two lines. They intersect at 4, 8. All right, we have one more example to do, and that's of a special case. So again, we have a system of two equations, and once again, we have to decide which variable to solve for. None of these will give us just a one-step equation. However, to avoid fractions, I think we'll solve for y again. So this time, if you subtract 4x from both sides, we still haven't solved for y. We have negative y by itself. So to finish this out, I need to multiply by negative 1 on both sides of the equation, and we'll get y equals 4x plus 1. So the logic of the substitution method is we have y equals 4x plus 1. That came from the second equation. So we're going to substitute into the top equation. So I have to write this down. I'll go over here this time. We have negative 8x plus 2 times y. But we know that y is 4x plus 1. That equals negative 5. So, finish solving this equation. We have negative 8x plus 8x plus 2 equals negative 5. So now alarm bells should be going off in your head because the x's cancel. We have 2 equals negative 5. Well, that equation is not true. So let's think to the past when we've been doing equation solving when we've seen that. When you're just solving just an equation with a single variable, if the variables cancel out and you're left with a sentence that's not true, well, we're going to write the same thing we did back then. There's no solution. Now, in the case of lines, what's really happening here, if you were to graph both of these lines, they'd be parallel to each other. And parallel lines don't intersect, and that's why there's no solution. There is one more possibility that I want to mention without doing another example. Let's say that you were solving a system and the variables canceled, but you were left with negative 5 equals negative 5. Well, that's a true sentence. And the answer here, again, is the same as it was back when we were just doing equation solving. What this means is that there's an infinite number of solutions. Now, don't write all real numbers because the solution to a system isn't a real number. It's a point. It's an xy pair. What this means graphically, if this were to happen, what that means is the two equations you started with were really the same equation. So the graphs you would have would really just be the same graph twice. Now it seems kind of silly, why would you ever want to deal with that? And it's true, in Algebra 1, this case where there's an infinite number of solutions is kind of silly. But when you move to 3 or more dimensions, this case is actually interesting. But for now, just remember, if the variables cancel and you're left with a true statement, there's an infinite number of solutions. Anyway, that's systems by substitution. Hope that helped.